Hello everyone, welcome to my channel. First of all, very happy new year. So recently I have added the simulation nodes in the animation nodes and extra nodes. Therefore now it is possible to do different kind of simulations in the animation nodes. For example, Spline Tracer, dynamic vertex color paint or vertex fade, custom particle system, melting the objects and many more. So in this video I'll explain the simulation concept and simulation nodes, and then I'll show you how you can make the Spline Tracer or General Tracer node with the simulation nodes. And the General Tracer node allows you to trace any list which is available in the animation nodes. So for the other simulation effects, I'll make separate tutorials because it is hard to cover them in this video. So for updates, subscribe to my channel and do support me, that help me to make this content. So now let's get started. So first I'll explain the simulation and simulation nodes. If we go by the definition of Wikipedia, a simulation is an approximate imitation of the operation of a process or a system that represents its operation over time. So for example, here is a cube and a force and a particle system assigned to this cube. So this is the initial state at the start time. So as time progress, the location of the particle is being affected by this force, and after some time we get the final state. We can understand the simulation from this flowchart diagram. So at the start time we have the initial state, and this is also the current state. So using the physical laws and math operations, we can calculate the next state from the current state for the next frame. When we add the next frame, the calculated next state becomes the current state, and this loop repeats over time and we get the simulation of the system. So based on this simulation concept, I have added the simulation nodes. So we have two nodes, simulation input and simulation output. The simulation input node is similar to the current state, and simulation output node is similar to the next state. In the simulation input, you also define the start and end frame of the simulation, and you input the initial data, and then you perform the math operation in between these two nodes, and then you connect this to the simulation output node, and the feedback system is automatically handled by these nodes in the background, and so you don't need to worry about that. And you can also take output from this link. This is the flowchart diagram for the simulation nodes. And one more thing is these nodes also work in the loop node and group nodes. So you can add the simulation input node from this newly added category simulation, the simulation input node. And if you press this button, you get the simulation output node corresponding to this simulation input node. So keep in mind that they have unique simulation input and output nodes. If I duplicate this and see, they have different color. And another thing I like to mention is that this node work for all these settings, but if you face any glitch in the render, then turn off all these settings except the frame change. So now I'm going to keep these settings. So now I'll make a simple simulation system in which we're going to move a vector along the x-axis. And probably you know about this data type. This is basically the set structure or get structure elements, and I have also added these nodes here. So set structure elements is similar to collection, and this node allow you to create a structure of different data types. So in this case we need a vector, and also we can hide this structure. And one thing you keep in mind that the naming of the inputs is important. So if I add this another input by same name, it only going to store one of them. So keep that in mind. Then I'm going to duplicate this and connect this to simulation output node. And for this we going to need a get structure and connect this to get this output. So we have this basic setup, and if I add this 3D viewer node, we can see the vector in the 3D viewport. So this vector is basically at 0, 0. So if I run the animation, this vector is not changing. The reason for that is we haven't added or modified this vector here. So let's add vector math node and add small amount of in the x component. And if I run the animation, see this vector is moving along the x-axis, and we can also change the y-axis of this vector as well. So I'm going to change this to 100 because our time range for this animation is 100. So this is the basic simulation system in which we move the vector along the x-axis. Now we're going to make the Spline Tracer group node. So here is an empty which is animated for 100 frames. So the idea for tracing is that we have to store the location of this empty for all these frames, and then we're going to make a spline from those locations. We need to store these 100 locations, therefore we need a vector list instead of single vector. Also here type vector list, and also we don't need math node, vector list. Okay, and connect this to 3D viewer node. So we have the initial empty list. So now we have to add the location of this empty to in this list. So first get the location of this empty, which is this, and to add this location to this vector list, we're going to use the node append to list node and append this location to this vector list, and also connect this output to the 3D viewer node, and also connect this to the location of the empty and change the color to green. Now if I run the animation, we can see that we are tracing the location of this empty. So to make the spline, we're going to add create from points node, and then we need the object output node, this, and if we hide the vector, we can see that we have generated a spline for the path of this empty. So this is a simple setup for this empty. But what happens if we have multiple objects or multiple vectors that we want to trace? So one way to do this is we can use a loop node. So add the loop node and disconnect this, and we're going to add iterator as vector list and connect this to this element, and I'm going to name this as an Spline Tracer loop, and also we need to output these splines. And let's make frame for these nodes. Okay, so to get the location for both the objects, we need to make a object list. And if we connect this to transfer input node, we get the location for both the objects. And now we can add the invoke subprogram for this loop node. Connect this to vector list and this to spline. Now if I run the animations, we have the splines for both on these empties. This is easy method, but it is not very efficient. Let me show you that. If I add wiggle vectors and connect this to the vector list, and then we need time info and connect this to the evolution now, and change this count to be 100. Now if I run the animation, we can see that we are tracing the 100 vectors, but the speed is very slow. So there is another way to achieve this almost real time. So for that, we're going to store all these vectors in a single vector list in the simulation nodes, and then in the end we're going to slice that list for each vector. So let's copy this setup, Shift D and Alt P, and we need to add the output simulation node. Instead of single vector, we have a list. So to add this list to this vector list of the simulation node, we have to use another node, which is the combine vector list node. So this node will combine these two lists and make a bigger list. Okay, and let's also add 3D viewer node so that we can see the trace locations for these vectors. And for vectors, I'm going to increase the size and also the color. Now if I run the animation, you can see we are tracing all these 100 vectors, but the speed is very fast. So now only thing we have to do is we have to slice this single vector list for each input vectors. So let's make this 5 for easy to see them. Okay, we have 5 input vectors. Okay, to slice this list, we are going to use a slice list node. And if you don't know about this node, it is very powerful. Let me show you. Okay, here we have the integer list, and this is our original list, and this is the list after the slice node. So if we set the start index, then this node is going to ignore the elements of the input list before the start index. So if I set to 2, see it start from 2, 3, 4, basically 2, 3 and 4th element. Ignore the 0 and 1. And in the end we have two settings, index and length. And index basically give you the elements before this index of the input list. Set 3 gives 0, 1, 2, not the 3. And if we change this to length, we get the from start to the whatever the length amount we have defined here. We set to 4, we get the first 4 elements, and so on. and then we have step. This parameter is very interesting. So this step allows you to skip the sum of the elements from the input list. So 1 is gives you the same list, and if I set to 2, it's going to give the elements of the indices which are multiple of 2, 0, 2, 4, and if I set to 3, going to 0, 3 and 6, then 9 and so on. So in this case we are going to use start and step. The step will be the number of input vectors, and start will be the index for these input vectors. So delete this and connect this to this vector list, and I'm going to add this here 3D viewer node so that we can see the sliced vector list. Change this color, maybe red. So let's get the number of input vectors, and in this case it is 5. And see, for the first vector we have this, it is a sliced list of locations. Then for second, third, fourth and fifth. So now only thing we have to do is, if we use the loop node, we can change this start index and get the sliced list for each individual vectors. So let's add the loop node and connect this to parameter to this list. Name this as vector list, and this index will be the start parameter for slice node, and step we're going to input from this length of the input vectors, and then we're going to convert this to a spline, and we have to output these splines from this loop node as well. And I'm going to name this as a slicer for splines. Make a frame for this and connect this list to the vector list, and this as a step, and how many iteration is the number of input vectors. If we connect these splines to this object output node, we get the curves for these wiggle vectors. Let's hide these empties. Now if I change this number to 100, see, it is much faster than this setup. Okay, another thing we can add here is that we want to only trace the application for these wiggle vectors for latest say 20 frames, not from the start but latest 20 frames. That is also possible. So let's first make a group node for this setup, then we will do that. So disconnect this and also disconnect this. So let's add a group node and type here as vector list and connect this to this reroute, and I'm also going to output the start frame and frame of this simulation input node, and for output we need to output this list and this step as well. So name this as vector list, this as iterations slash step, and I'm going to name this as location tracer. You can also, I think, instead as a location, as a vector list, it is more consistent. So let's make frame for this. Okay, so now we can add this invoke node here. Connect the vector list and this to the vector list of slicer node. I think I have misspelled here. No, slicer. Okay. So now we have this setup for these wiggle vectors. And okay, to trace only a certain length of frames, we have to add that here. Integer, name it as length in frames. So let's type some value here, maybe 20 frames. Okay, so for each input vectors we want to trace only 20 frame length, because this is a single list, so we have to multiply this frame length by the length of input vectors, then we get the total length that we want to keep from this single list. Let's also delete this 3D viewer node. Okay, now we have to do is only want to keep this 100 elements of this list. So first we have to get the length of this list, then we are going to subtract this list from this length, and that will give the number which we have to slice or get the list after this index. Let us add the slice node, enable this start, and this will be the start index, and this is the list. And now connect this to the vector and this to the group output node. See we have the spline length of 20 frames for each vector, and one thing we have to do here is that at the start frame this number can be negative. Okay, so we have to add the separation maximum here, so it will only give the positive values. When it is negative, then it will give the 0. So we have only length for 20 frames. And for grease pencil, just we have to copy this setup and change this name to strokes, and also delete this, and we have to output the stroke list. and then add the stroke from points node. So this setup will give you the grease pencil tracer or stroke tracer for these vectors. Okay, now I'll show you how to trace. Use the same method to trace the mesh. So let's disconnect this node from here, and I have animated a cube which change shape as from 1 frame to 100. So we want to trace this cube. So first we have to get the vertex location of this mesh. So connect this and select this cube, and now we have the vertex location. And if I connect this to 3D viewer node and also change this to 100 frames so that we can see the locations. So we are tracing all the vertices of this cube. So for slicer setup, I'm going to copy this and also delete this as well and rename as meshes. So for this slicer we have to slightly change the setup. The reason for that is here we are getting the locations for each individual vectors, but for mesh, to trace this mesh, we have to get the location of all these vertices for each frame, not the individual vertices. So for that we again going to use the slice node, and if I connect this slice node to this vector list and then this to the 3D viewer node and change this to length, and the length will be the number of input vertex locations, in this case 8. Now see location of all these vertices at the first frame. So if I change this to 9, we get the location for the second frame. See, 0, 9, and then if I change to 18, that's for the third frame. So this is nothing but the multiple of this number of input vectors. So the only thing we have to do is we have to get the number of current frames. In this case is 87. That we can do in this setup by dividing the length of this output list of vectors by the input number of vectors. And if we change this to divide, we get the 87, and then we have to convert into integer and then connect this to the group output node, and I'm going to name this as iterations for mesh, because this is only going to use for mesh, and also hide this by default. So let's delete this. So connect this vector to vector, and this is the iteration and this is the step. So in this loop node, we're going to delete this and enable the end, and that will be the step this into length and for the start we have to multiply this by the number of input vectors or the length. Now we have the correct vertex, and then we can convert them into a mesh. And let's add mesh list node, and here this is the length basically, and for mesh edge indices and polygon indices we get from the original input mesh. So edge and then polygon, and now output these mesh list as a mesh object. We get this. See, we are tracing that cube, and we can also make for 20 frames as well, length for 20 frames. There is also another way which is more general, but it is slightly memory expensive, in which we can trace any list which is available in the animation nodes. So for that we have to copy this setup, and I'm going to show you for the mesh list, but you can make the same setup for other lists as well. So change this to name this as tracer, mesh tracer. And now we have to add the output node, simulation output node, and then because we are doing for a mesh list, so we need the input mesh list, and here as well mesh list and mesh list, and here as well mesh list and mesh list. So let's add the combine mesh list node, and connect this mesh list, and also for slice list duplicate this and connect the mesh list, and this output to the mesh list, and also we're going to output that mesh list to the group output. And we don't need these setup, and also this, and also the vector list, and then we can connect this to the get length, and here as well. So let's delete this vector, and also this to the start, and delete this, and also delete this vector list. Okay, so we have only the mesh list. So I'm going to move this mesh list to the top. Okay, now if I create the invoke node and change this frame to 20 and connect this to mesh list input of this invoke node, and this list to the join mesh list. Now if we run the simulation animation, we get the same effect. See, there is no difference here. they both are same. But the nice thing about this setup is that you can do for any kind of a list, a mesh, a spline, grease pencil, layers, text object, or anything. So this is more general setup than the previous one, but this is more efficient one for this to trace the grease pencil, mesh, spline tracer. Okay, now I'll show you how to apply this spline tracer onto a model. So let's disconnect this and connect this vector list to the spline slicer, iteration to the iteration, and step. Also hide this iteration for the mesh output. So now we have to supply the input vectors of the model. So here is the model that I have downloaded from the Maximo website. So there are many models for different animations. Okay, for this model I only want to trace points on the hands or on the feet. So for that I have added a vertex group, assign weight 1 to the vertices which are on the for the hands or for the feet. So let's add this model here, and we have to enable the use modifier because it has animation. And to get vertex locations of the hands and the feet, we're going to use mask list node, and for the mask we're going to use the weight that we have added, and select this object, and I'm going to change this to name. Type the name of the vertex group, which is select. We can see the vertices, see only vertices on the hand or feet. So then I use get random list elements node, and I'm only going to trace the 100 points or 100 vertices, the feet as well as on the hands. Now if we run the animation, see we're getting the splines for those points. Okay, let's smooth these splines by using smooth bezier node. Okay, this is the setup to trace splines for a model. So this is my project file where I have added a simple background and also a simple material to these splines. So this is it for this tutorial. I hope you like this work, and please do support me and subscribe to my channel for more updates. Please like this video and share this video so that other people can see this and take the benefit from the simulation nodes. So until next time, happy noding, bye.